Okay, hi, it's Mrs. Leganke here. Here is your end of the unit study guide, and I've gone through and explained it. CS, if you have any questions, go ahead and put your name at the top and the date and the class period. Question 1. Two rectangles with the same side lengths are always blank. Draw a picture to justify your answer. All right, so before I come up with that word, let me make two rectangles with the same side length. So I'm going to do that now. Okay, so let's take a look here. Here's two rectangles with the same side lengths. And I would say as long as they have the same side lengths and they're rectangles, they would be the same. They're always the same. That math word for being the same is called congruent. So in this space, we're going to put congruent. And then referring back to the picture, that would mean this side, it's two sets of parallel sides. So those sides are always going to be the same. And then the length would always be the same. And then the angles inside, if it's a rectangle, that means these are all 90-degree angles. So as long as the two rectangles have the same side lengths, they'll always be congruent. Which of these sequences of transformations would return a shape to its original position? Okay, to show you this, I'm going to pull up a little graph here so we can kind of see them all. Okay, beginning with A, we're going to reflect over the x-axis and then reflect over the y-axis and see what happens. So I'm going to begin with a shape, or I'm going to just begin with a point. So I'm going to put a point here at 4, 1. And let's first reflect it over the x-axis. So it would be down here at 4, -1. And now reflect it over the y-axis, so it would be right here. So you can see it goes from here to here and here to here. It does not come back to its original position. So A is out. Let's try B. Okay, now we're going to rotate 90 degrees clockwise around a point and then rotate another 90 degrees. So 90 and 90, so we're going to rotate 180 degrees. To be back in its original position, it would have to do a complete 360. So I think this one's going to be out. But let's go ahead and take a look here. So let's say I have a triangle. Okay, so here's my triangle. I'm going to rotate it around this point right here. So if I go 90 degrees, that's going to be one turn. So I'm going to turn this once. Okay, so it looks something like that. And then I'm going to turn it twice. So another 90 degrees. So it would end up being like here, like a 180. That's not quite right, but you can see it's not going to fit back inside itself. So rotating it twice would not work. I'd have to rotate it a full 360 degrees. Okay, so that one's out. All right, next up is translating 5 units up and 3 units to the right. So we do that first, and then we're going to translate 3 units to the left and 5 units down. This one might work, so let's try it. Let's start, I'm going to start right down here. Okay, so let's go 5 up, 1, 2, 3, 4, 5, and 3 to the right, 1, 2, 3. So we'll end up right here at -1, 2. And then we kind of reverse it. We're going to go 3 to the left. So we're going to go back 1, 2, 3, and then down 5. 1, 2, 3, 4, 5. And I'm back where I started from. So this is the correct answer. And then just to see the last one, there, sorry about that. Pull another graph here. Translate 3 to the right and reflect over the x-axis. Trying to make this one go away here. Okay. Let's go 3 to the right. So I'm going to put a point right here. And we're going to go 3 to the right. So 1, 2, 3 right here. And then reflect over the x-axis would be down here. So that does not bring us back to the original point. So our correct answer was C. For question 3, we're going to plot the image of triangle ABC under a reflection across the x-axis. So your first step would be to identify the x-axis. That's right here, the horizontal line. Now we go point by point. Our first ordered pair, or our first point A, is already on the x-axis. So since A is already on the x-axis, A prime would stay right there on the x-axis as well. Moving on to B, since B is at -6, +5, it's 1, 2, 3, 4, 5 places away from the x-axis. We reverse that and go 5 places down, and we would plot B prime right here. Moving on to C, C is 1, 2, 3, 4 places away from the x-axis. So we reverse that and move 4 places flipped over the x-axis. So C prime would be right here at -4, -4. And then neatly connect to make your triangle. And it should look like a flipped image, which it does there. Question 4. How could you prove using mathematical language that these two polygons are congruent? The word congruent means the same shape and the same size. So by looking at the two polygons, it does appear that they are the same shape and the same size, but we have to use mathematical language. Well, one thing I notice, and since I'm able to do this on this program, I can rotate the polygon and it fits exactly inside itself. So one thing we could say is a rotation can be applied to the figures and then they would be congruent. They would fit inside itself. So that's one piece of mathematical language we could use. So I went ahead and typed that in. You could go ahead and write that on your notes. So the fact that they can be rotated would prove that they would be congruent because rotations produce congruent images. The other thing I notice is, did you see this point right here and this point right here? Those appear to be the same angle. So we could also note that the angle measures are congruent. So that's a second thing we can say, that angle A would correspond here with A prime. And then a third thing I notice is this point right here appears to match up with point C. And then if we drew a line segment from A to C and A to C prime, that line segment, we could use a ruler and that line segment would match up. So that's the final thing to note, that line AC would be congruent to line A prime C prime. So the rotations prove it, and the angle correspondence and the line segment. Question 5, find the value of x in the triangle below. Well, we know that all three of these angles, when we add them together, have a sum of 180. So I would add 50 and 41, which is 91. And then you go ahead and subtract that from 180. whatever method you choose to do. So that's going to be 89 degrees. So 89 degrees. Below are two parallel lines with a third line intersecting them. That's a transversal. We're going to find the value of x. So if I use tracing paper like we did a few times before, if I traced the angle, I'm doing it here in purple. All right, a little bit off there. If I trace the angle and then I translate the angle, I slide it down here. Do you see how it matches up perfectly? And then even if I rotated the angle, it also matches up perfectly. So it is an exact match. They are congruent. You may have also been familiar with the term alternate exterior angles. They're outside the parallel lines and they alternate the transversal. Either way you look at it, it is the same measure. So 56 is x. And our reason could be they're congruent. We translated them or rotated them. Also, alternate exterior angles are congruent. Okay, question 7, we're looking for the measure of angle x. So we're looking for right here. And we have a lot of information. We have 56 degrees right here for angle H, and we know angle K is 60. I also see right here is a set of parallel lines, and I'm noticing that this angle 60, if I had tracing paper, looks congruent to measure I. So let me trace that and translate it, and yep, they're the same. So if angle K is 60, then angle I right in here is also 60 degrees. Now we have a triangle. Do you see it? So these three angles added together should have a sum of 180. So I'm going to add 56 plus 60, which is 116, and then I'm going to subtract that from 180, which leaves me with 64 degrees for angle X. Okay, so that helped kind of eyeing up the picture and translating, and then using our triangle sum theorem. Okay, in the following diagram, BC is parallel to DE. What is the measure of angle X? And I first have to identify a pair of congruent angles in the figure and explain how I know that they are congruent. So I'm going to use that tracing paper idea, and I'm going to look at angle X here. It looks to me like it's probably congruent up here to angle BCA. So I'm going to check out this angle right here. If I translate that, slide it down, that's a match, and then I'm going to rotate it, and yep. So that measure, that angle right here, let me mark it in yellow, this angle and angle X are congruent. When you name an angle, you give 3 letters. So let me highlight the angle I'm looking at. BCA. I'm going to say that angle is congruent to, let me change the color here, to CAE. Those two are congruent. Okay, so I named them, and this equal sign with a squiggle, that means congruent. So BCA is congruent to CAE. And how did I know? I could say I used tracing paper and I rotated the angles and they matched up. I also noticed that they are inside the parallel lines and they're alternate interior angles. So I'm going to use that reason. Okay, so alternate interior angles are congruent. Now, step 2 is to find the value of x. So, do you see the triangle that is inside there? We have 42, 109, and this unknown measure. So we're going to have to do that math. 109 plus 42. We're going to add that up and subtract from 180 to get that missing angle measure. So that adds up to 150 and then 100 or 151. 180 minus 151. Okay, so that's going to be 29 degrees. So 29 degrees up here, and alternating interior angles are congruent. So the value of x must also be 29 degrees.